When you think about a television network, you probably think about a big studio in Hollywood where they make TV programs. Well, a television network really is a network in a way. There's a big central processing system in New York where they have lots of programs, hundreds of users scattered all over the country, sharing those programs, exchanging information along lines or satellite links. Now, the technical aspects of a television network are in fact pretty simple compared to the complexity of a computer network. Today we begin a special two-part look at PC networks on this edition of the Computer Chronicles.
The Computer Chronicles is made possible in part by CompuServe, featuring an online reference library, Wall Street reports, at-home shopping, airline reservations, games, and hundreds of other services. CompuServe, helping people get the most from computers. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover developments in computer technology worldwide.
Welcome to the Computer Chronicles. I'm Stewart Cheifet, and sitting in this week for Gary Kildall is George Morrow. George, at the beginning of the program, I made an analogy to a television network or something like a computer network. In fact, if you look at these two schematics, this is the PBS network and this is a computer network, you can see the structure is really very similar.
It is.
I want to ask you, George, with something like the 386 PC now, does that mean it's easier, cheaper for someone to get into a network situation?
It sure is, Stewart. These machines are going to move the price performance points of network systems a big step. The processors are very powerful, very capable, and the I/O buses have been designed to move data onto and off of a network and onto and off of a disk very fast.
What about a Mac 2?
Well, the Mac 2, it's also a very capable machine. The 68,000 processor family is just as capable as the 386s, and the new bus on the Mac 2 is a very fast bus also.
George, on this first program dealing with networks, we're going to focus on the PC-DOS environment. We'll see some very big network systems, things using 3Com's Ethernet, Novell's NetWare. We'll also see some small network systems using products like Grapevine and EasyLAN. We're going to begin by taking a look at a very big token ring network in Concord, California. It's running off of Burroughs mainframe.
In the San Francisco suburb of Concord, the closest thing to a network at City Hall used to be this pneumatic tube system, a reliable but limited solution to the problem of moving documents between different offices. Today, computer networks are transforming city government, department by department.
Initially, the sort of desktop productivity was the main spur. Department level word processing, the ability to get the documents out on time and with a consistent format. Spreadsheet applications, you know, everybody has to do a budget. And list maintenance. Typically within a department you have files or records of information that really aren't that relevant to anyone else, but they're very important to you. And the ability to be able to have an easy retrieval process for recalling those records. At a department level to get rid of all the boxes of index cards, you know, 3x5 cards and Rolodex lists. I mean, they were everywhere. I wanted to consolidate that.
In the city clerk's office, at the Public Works Department, and at Central Word Processing, token ring networks have simplified the complexity of storing, finding, and changing documents that are handled by many different people. The bureaucratic process seems to be well suited to the network's functions.
Where you have data coming in regarding a code violation out in the field, and that gets resolved on some basis, and the person who detected the violation could be different from the person who entered the violation, could be different from the person who resolves the violation. And you'd like to have an electronic system that eliminates the lookup and searching and stuff that is required for that.
Concord's networks are not yet interlinked. Each department has its own system and its own file server. In some departments, where a network's usefulness is limited to transferring files and sharing peripherals, computers are linked together with just a simple RS-232 smart connector. While most workers have adapted to the network system, some paper backup files are still apparent. And making the software as user-friendly as index cards hasn't always been easy.
Applications that are designed for the network aren't too difficult to reap the full benefits of the networking. Applications that are really designed for a single user environment where you have utilities to allow you to make it function in the network environment, but it requires a little bit of creativity on your part, since many features of the network can only be activated at the command prompt level. I think the next thing now is to come up with a look and feel that's consistent with other types of systems, logical systems that people use. Like in the phone system, you're used to the idea of a prefix, a phone number, and an extension. People can deal with that, an address and a zip code. There's a metaphor that allows you in your mind to internalize what's happening with this information system.
Joining us in the studio now is Ken Scott. Ken's president of Computer Pathways, makers of Grapevine. Also with us at the other workstation over there is Warren Sly, vice president for marketing at Computer Pathways. George?
Grapevine is an interesting name. It suggests a very interesting product. Perhaps you could tell us a little about it.
Well, it is an interesting name. We chose it very carefully because it suggests that people should already know how to use the product.
Right.
And right at the outset, that's what we designed. We thought that it would be preferable to have a local area network that the average or typical PC user, one who's familiar with spreadsheets or word processors, ought to be able to use the first time that they see it.
Topologically, the network's a little bit different than having a local, having a dedicated server. Is that right, Ken?
Yes, very much so. What we have done is we have provided the capability to put the server function throughout the network. And therefore, each station making up a network can be a server, and therefore provide server functions to any user on the network, rather than having a dedicated server where that's where everything has to reside.
So it's distributed?
It is distributed, yes.
And I think you have a demo that you're going to show us.
Yes, let me first acquaint you with the setup here.
Sure.
Warren is operating a system over here. It's comprised of ATs and XTs. He's running a word processing system. We'll be running a spreadsheet on this. And in the compact, we'll also be running, I think, just stable here. We had a database on it before.
So this is a system with 3 nodes?
3 nodes, that's correct. And the system is capable of having up to 50 nodes spread over a distance of 4,000 feet.
Each one of these nodes can be part of the server network then?
Yes, each node can behave as a server, so that when you install the network where you have the printer already, it can stay there. It doesn't have to move to where the file server is located.
Show us how Grapevine works here, Ken.
Sure. Let me just make a point that networks comprise 3 areas of functionality. They provide the ability to share physical resources like printers, to share files either on a single user or multi-user basis, or to provide communications among members of the network.
That's right.
Now what we're doing is we'll demonstrate this while at the same time we're running Lotus 123, which in itself is a distinction for the product. Most products will not allow you to gain access to the network functionality unless you exit from your application program. In this case, you can bring the network capability to the foreground immediately by pressing one key. And here what we're showing is that there are several printers that are available on the network. But another aspect of it is that notice that the LQ1500, we have different variations on that printer. We can do compressed print off this menu, we can do letter quality, or we can do draft quality.
So these are, in a sense, a certain amount of the resources that are available.
These are the resources on
right
this
while you're running an application.
That's right. So in this case, we're running a spreadsheet, and if I wanted to send the print job to any one of these printers, I would just simply go to the menu and make the selection. I'd be notified that that selection was made.
I see.
In the next menu, what we do is we show you what jobs, if any, are associated with that particular printer or resource that you've selected. We also give you the opportunity to select and look at the jobs associated with any other printer on the network itself.
I see.
You also, in this menu, you're allowed to manage the jobs. For example, if you want to rearrange the priority, you want to move a job to the first head of the queue, or you want to cancel a job, or a large job, you may want to defer its printing by putting it on hold until later on in the evening. The next menu describes what we call derived substitutions, and what it really allows you to do is, because it is a distributed network, you were able to gain access to files located on machines throughout the network, rather than having just those files on the server being shared by people.
Now, how about the file lockout problem? Suppose one user is accessing a file. Can another user access the same file in this environment?
In a multi-user system, there is a locking provision where a user is locked out either of the file or the record associated with that file. If it is a single user version, yes, both users can gain access to it. It's really the application program that's going to drive that.
Okay.
Also, we provide multiple layers of security associated with each of the files. So a user can lock people out of all of the disk drive or just portions of the disk drive. Or they can provide the facility for someone to come in and just read it or to just write into that particular file area. The next area that I'd like to demonstrate is the email. And the email facility here is quite robust. We're allowed to create what we call e-forms, which is unusual to the system in the sense, excuse me, we can create an e-form here which says to, from, for example, and we can create a memo pad that's unique to the system.
So there's a standard email form you can call up.
Exactly, but you can customize it to your particular work activity.
If you want to.
If you want to. Now just simply save it with the name of memo.
And you can call that back up as a framework to send messages back and
Yes,
forth.
in fact, I'll call it up now.
I
And you can see part of it is filled in for you. If I had to put date on there, it would have filled in the date. Time, it would have filled in the time.
Good.
The options available in email are pretty impressive as well. For example, I can send and continue, which means I can send mail, I can send rough drafts, I can file it, I can store it, I can save it as an e-form or whatever else. And I can send it off to be printed if I wanted to. Now, one of the observations I think is important is that we've been working this all the time we've been in Lotus 123. And that's a key attribute because we haven't had to leave the application program in order to take advantage of changing files or gaining access to the email.
Ken, Lotus is running under MS-DOS, isn't it?
That is correct.
And the relationship of this software with MS-DOS, how would you describe it?
Intimate.
Well, is it co-reside with MS-DOS or does it?
It co-resides. It's a RAM resident process. It's a real-time multitasking operating system. And what it does is it treats MS-DOS and other things as different tasks and manages those tasks as well as the server responsibilities.
Ken, what are the advantages then in general of your approach, Grapevine's approach to a network, as opposed to the traditional first-generation LAN with a one-file server?
Well, I think there are several. One is that you avoid all of the congestion that's normally inherent with a dedicated file server. With a dedicated file server, the more users you begin putting onto the network, the more traffic flows into it, and therefore the performance of the network degrades very badly. The second thing is you're able to distribute your physical resources in a more pragmatic or realistic fashion. You don't have to be tied at the other end of the building to a
So if one user is using a certain group of files, it's more natural to put that on the drive that he's with so that he doesn't tie up the network as much.
Of course. In our system, for example, we have somewhere in the neighborhood of 20 users up at one time. We have 3 or 4 multi-user programs running. We're sharing files, we're doing email, and we have yet to see any network degradation at all.
You know, that's the usual complaint about the network situation. The 20th guy gets on and it takes him forever to access something.
That's
You're saying
right.
that doesn't happen in this approach?
It does not need to happen simply because the resources that will be shared amongst members of the network are distributed throughout the network rather than funneled into one particular drive.
The other thing that occurs to me is that if the resources, if one person's using the resources, they can be moved to his part of the server rather than having to be remote.
Quickly, just about 30 seconds left. What is Grapevine? It's hardware and software, right?
It's a combination of hardware and software. The hardware consists of a single card which you insert into the machine itself.
Into each PC, it's part of
Into
the
each
system.
PC. There's a cabling scheme. It can be either coax or twisted pair. The distances I measured, as mentioned before, can be upward of 4,000 feet spread. And it's a single disk software product. It takes about 128,000 bytes in RAM.
Ken, there doesn't seem to be an awful lot of silicon on that board compared with something like a token ring board or one of the Ethernet boards.
Yeah, it's a rather remarkable amount of engineering that went into this to provide the level of performance we have. And this allows us to provide it to the customer at a very inexpensive price.
Ken, thank you very much. Now we're going to go from the simple to the relatively complicated. We're going to take a look at an Ethernet system. This has 4 file servers, more than 60 workstations, 640 megabytes. Wendy Woods reports from Computer Associates in San Jose.
Computer Associates International, the world's largest software company, doesn't fool around when it comes to efficiency. All programmers, engineers, and quality control people work on computers linked through a 3Com local area network. The network provides them with two important benefits. They can communicate and program far better than if they were working on standalone terminals.
By working with the network, we are able to share data. So one person can be working on a module on his own, working on the features that he needs to do, and he can integrate it with the other programmers' modules immediately and be able to test his code with the latest that everyone has. And then quality assurance can immediately test that code because it's up on the network and they have access to it. So people aren't constantly passing along floppy, trying to copy things to floppy disks and passing them around.
In addition to the 3 file servers, which act as the traffic cops for all 70 of the department's computers, the network also has what's called CPU servers, powerful computers to which jobs can be offloaded. They compile code and do number crunching, freeing a programmer's individual machine for other tasks.
We have CPU server tools that allow us to keep track of jobs going on. We have several things that allow us to track files, to be able to communicate. We have an email service that really aids the communication.
And by working on a local area network, programmers get first-hand experience programming for local area networks, which enhances the 100 or more products that Computer Associates creates.
Okay, and you're still not getting individual cost and sales information? Okay, where are you setting it up at?
In another part of the firm's San Jose headquarters, customer service and accounting people work on a Novell local area network. This system tracks the entire telephone support operation, from the time of a customer's call to its outcome. Eventually, the people here want to link both the customer support and the engineering networks. Bug reports and customer suggestions could be put on the same network for both departments to share. Right now, this information is transferred the old-fashioned way, on paper. And finally, there's one other old-fashioned idea still in effect here: personal interaction. Despite the efficiency of the network, programmers still need to get together and exchange ideas in face-to-face meetings, something a network has yet to replace. In San Jose for the Computer Chronicles, I'm Wendy Woods.
With us in the studio now is Dick Kent, president of DLM Consultants in Santa Clara, and next to Dick is Bill Myers, director of sales for server technology in Sunnyvale. Bill, your company has yet another approach to local area network, something called EasyLAN. Describe that to us. It's described as a zero-slot system or an RS-232 system. What is that?
We like to think of EasyLAN as the low-cost network alternative. That doesn't mean necessarily it's less functional in many ways, but by RS-232 we mean that we utilize a signaling scheme that's inherent in virtually all of today's PCs and PC compatibles. That's the serial port. Users know that from using a serial printer or a modem. We simply have a cabling scheme that hooks right up to the serial port, and with our own software we create a network.
And what kind of capabilities do you get out of that?
You get what we think are the important functional capabilities that users in a network tend to look for first. Sharing expensive peripheral devices like printers. Today's laser printers tend to be the kind of thing people want to share. Being able to exchange a file. Someone working on a letter wants to have someone else see it or work on it. You can do that on EasyLAN. It's rather than having to copy a disk and walk it across and give it to someone else. So those kinds of things.
Now, when you have to get up to multitasking or file sharing where you're real-time sharing files, your system doesn't have that capability.
Clearly, we do not provide that capability.
But now, if someone needed to add that, would they have to throw away your system, or could they keep it?
EasyLAN can run in another environment right along with any other network that would provide that kind of functionality.
Okay, so with EasyLAN, no board.
Correct.
And the functionality you described. Now, we've seen a lot of approaches now to local area networks. Dick, describe the different ones and what are the costs and the trade-offs in each approach?
Okay, in the RS-232 approach like EasyLAN is using, the basic difference is the cost. The cost of the system is $100 to $200 per node. When you're talking about a traditional network like a Novell or a 3Com, you've got to talk about hardware costs, and the boards, called network interface cards, cost you between $300 and $500 a card, depending upon which network you pick. There's the network operating system, which can cost between $2,000 and $3,000 for up to a 6-user system. And then there's a difference between functionality between the RS-232s and the traditional networks, you can run multi-user programs on the 3coms and the novels. You can't do that on the
But it sounds to me like around $1,000 a node.
About $1,000 a node. It's a good
Now,
estimate.
when you're running a program like this or a network like this where there's a lot of horsepower and capability, how about the security aspects of it?
Okay, the question of security encompasses two areas. There's the unauthorized access to the network itself and the data on the network, and the integrity of the data in the event of a disastrous failure like a system crash or a power failure.
So that's probably on most people's minds when they put in these high-powered networks is what happens if the power goes out? What happens to the file server?
Okay, the first thing to be realized is that when you have a file server in a network, you should have a UPS or an uninterruptible power supply, which protects you in the event of a brownout or a blackout, and gives you from 5 to 20 minutes, depending upon the system, to bring your system down gracefully and close all the files and fix all the directives that have to be fixed. In the event that you don't have a universal power UPS in your system, the network operating system provides you with some forms of protection using duplicate directories, using disk mirroring with 2 separate disks, or in many cases redundant hardware, disks, controllers, and power supplies.
In your experience, when one or more nodes go out, are these systems pretty resilient? That is, can they make up for the fact that something isn't there?
A lot of work has been done recently, and there's a great deal of work continuing in this area. And the old effect of one node going down, like a ring network, which brings the whole system down, doesn't really exist today. The problem is in diagnosing where the problem is. What will happen in many cases is the entire network slows down. And you have
But
to
it doesn't die?
It doesn't die. But the response time may go to minutes instead of seconds.
I see.
Bill, about 30 seconds left. How is the local area network segmented? What's the target user for each of these different kinds of products, starting with yours?
I think that someone looking at a network probably needs to assess the objectives that they want to achieve with the network. I think those objectives start with something we mentioned before, basic functionality, and then you get higher levels kinds of functionality. Certainly resource sharing, then going to file sharing, and then going to multi-user kinds of applications where the applications are being shared sets up a sort of an assessment that a user needs to do. We provide a product at one end of that functionality and do not address another end. Other products address the whole spectrum.
Gentlemen, thank you very much. We're out of time. That's part one of our look at local area networks. Next week, we look at Apple Talk networking with Macintoshes. I hope you'll join us then.
I'm Cynthia Steele in the Random Access File. Keytronic Corporation, the nation's top keyboard manufacturer, announced the layoff of approximately 150 of its 2,000 workers. The company is facing stiff competition from offshore manufacturers. The company also has to absorb the cost of a $1 million cleanup of toxic waste at a landfill near the Spokane, Washington plant. Nevertheless, they have announced a new product, Quicksilver, a full travel membrane technology keyboard. It will be manufactured at a cost that will allow it to compete with imports. Western Digital Corporation acquired the assets of Tandem Corporation hard disk drive operations for about $49 million. The purchase fits into Western's plans to provide a wide variety of storage products. Those include integrated drives with disk and controller in a single package, integrated solutions where controller electronics are integrated on a motherboard and packaged with a standard disk drive, and one more, intelligent integrated drives with a local area network subsystem. Telenet announced the formation of the PC Services Group. It's designed to develop messaging services for the personal computer market. The group will develop future versions of Telenet's PC Telemail software for IBM and compatibles and PC Telemail for local area networks. They're also looking to develop programs for the Macintosh and other non-IBM computer. Laser printers may be in for some turbocharging, according to Raster Image Processing Systems. They've developed an 8 megahertz RISC processor that operates at 10 MIPS, utilizes a PostScript clone page that can boost performance by a significant margin. The company says a printer using its chip could show a 30-to-1 performance improvement. Time now for Paul Schindler's software review.
You know, back in the days of paper, you remember paper, don't you? When you ran across something you wanted to save for later, you simply cut it out. That's not as easy to do in the electronic era unless you have MemoryMate. It's simple and useful memory resident software. You can put anything you want into it. One key saves what you've written. The program asks if you want this used as a reminder system. Another key allows you to find any note. There is no indexing. The program can search 180,000 characters in 3 seconds. That's known as full text search. So you could look for Sam or Pete or any phone number from the 123 area code. You can cut a piece of copy out of your word processor and store it in MemoryMate. Switch to the word processor screen, start the cut, cursor to the end, switch back, and paste it into MemoryMate. Now you can find it again anytime you want. If you've already got an address file in a database, you can load it into MemoryMate and take advantage of free text search. MemoryMate, $80 from Broderbund Software in San Rafael, California. For the Computer Chronicles, I'm Paul Schindler.
Unix got a shot in the arm this week. Unisys Corporation, the nation's third largest computer company, signed agreements with AT&T and Sun Microsystems to bolster use of the multi-user operating system. Unisys will work with AT&T to enhance the operating system and will license Sun Spark chip for use on future Unisys systems running Unix. Apple watchers speculate that if and when Apple releases the laptop computer being developed under the codename Laguna, it'll be priced at $6,000. The word is the Laguna is a 12-pound portable with a stand-up active matrix screen, similar to those being used in some Japanese TVs. Lotus announced a shipment of Metro version 1.1. The program's about the same, except in how it uses your computer's memory. The new version is broken into 2 parts, a 64K kernel that stays resident and a user-defined larger block of accessories that occupies the high end of the memory and is swapped to disk when space is needed for other programs. Hertz, the rental car company, announced that they will equip 74 of their locations with kiosks that contain computerized driving directions terminal. You choose your destination from a menu, see a map on the monitor, and the system prints out a set of directions in your choice of English, Spanish, French, German, or Italian. Each kiosk is built around IBM PS2 Model 50 with a 20-meg hard drive, and it runs a database with about 350 local destinations. That's it for this week's Computer Chronicles. I'm Cynthia Steele.
The Computer Chronicles is made possible in part by CompuServe, featuring an online reference library, Wall Street reports, at-home shopping, airline reservations, games, and hundreds of other services. CompuServe, helping people get the most from computers. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover developments in computer technology worldwide. Transcripts of the Computer Chronicles are available online on CompuServe. Type Go Chronicles at any CompuServe prompt. If you'd like the CompuServe access number in your area or a free booklet describing how to use online services, call 1-800-848-8199.